So here what we are discussing is about understanding data centers. So today, most of our applications that you use are hosted somewhere in a data center, right? So uh, in a very simple sense, a data center is a facility that is kind of hosting your servers, your critical IT systems like storage, network equipment. Uh, Whenever as an organization we have to, so there was a time when we used to keep these servers and all this equipment within our offices. Gradually people realize that it is not that secure uh, for high performance applications, where we have to ensure that those applications remain up all the time 24 cross 7 round the year. We need specialized facilities to actually run, from where we can run these applications. So that is where data centers came in. Uh, a very simple thing is that if you have a personal computer and you have just left it on your desktop, someone has shut it down, or someone has removed your LAN cable, right? You have a very limited impact. Just a single user is impacted. But when you talk about your servers, which are providing services to lakhs of clients, millions of clients in some cases, if someone simply removes the power cable of that server, that is a very, very costly event, right? So the company may lose the business, they might lose their future growth, and the risks are just huge. Okay. So today, you know that when any social service goes down or a social media platform goes down, how big a problem is that, right? So we need, for our servers, we need a safe, stable, and secure environment. Again, depending upon the company size, a company may choose to just keep a server in a very secure place in the office. If I have a small office, where I can personally monitor what is happening to that machine. In a slightly larger office, we can still set up a server room, a separate room where we can keep 5 6 servers which we need, and ensure that it is properly secured. We use better equipments over there, better power backups over there, and so on. But once we go through to a very large scale setup, then obviously the first two things doesn't work out. So where data centers are needed, the world runs on digital services today. So data centers helps keep our apps and websites running 24 cross 7. They ensure that our important systems never go down. They protect user data, keep it backed up. So even in case of a failure of a server or a machine, your data is not lost. And we support millions of users at a same point of time. Yeah, okay. So we were at why are data centers needed? So at the end of the day, without data centers, most modern services from banking to shopping just wouldn't work. So now coming on to network connectivity in the data center. Now, one thing is there that how the devices in data centers like are working. The point is that obviously these data centers are uh, large buildings. They are remote. They are mostly established in some remote areas, which where you can actually get that much space. Mostly these are industrial areas, and uh, and they are connected to the internet using fiber optics. So, anyways, today bandwidth has become a very easily available thing. Uh, and So, if you go back some 10 15 years back, this was a very big problem, right? How much bandwidth we will have, because bandwidth was not that cheap. Uh, and also internet connectivity, how good is the connectivity, right? So those were very important criteria. But in today's time, I think what has happened is that we know that our entire likes of Jio and Airtel all are on fiber optic networks, so they are able to provide you a very good bandwidth, a very good transmission speed. But anyways, this is a very core thing for data centers because many businesses are getting connected to it, right? So they need to have a very large, very high capacity, and also very good speeds. In their network, they will use high core switches, routers, and firewalls and load balancers. So these will be the network part of it. Uh, they will ensure fast access with low latency and data routing. Okay. So as I was speaking, whenever you connect to your systems in data center, the connections will be super fast. They will have very low latency, and they will be easily able to provide you the data that you want. Okay. Another thing very important is that there is a lot of redundancy built in. So you can say redundancy is kind of a duplicacy also. So they will not just have one connection or one bandwidth coming or one provider coming to them. They will generally keep re- redundancy means even if one connection fails, the data center is still able to provide you the services. So that is why they become so much reliable. Okay. Generally, in India, there are many data center companies today. The few ones which are a bit older, like Control S is there, SIFI is there. But now you also might have heard about Nota. It's a data center from uh, uh, so different companies now are establishing. You might have heard about NTT data centers. You might have heard about this Nota I have just told you. There are many others, right? So generally, these data centers will be huge buildings in which there will be racks and racks of servers, and servers will be mounted on it. So this is a typical server rack on the left hand side. You can see there are slots in it where servers are going. At the back of these servers, all this cabling happens. This is also known as structured cabling. So we properly insert the cables and take them to the switches and the electricity devices and so on. Uh, So what are the core components of a data center? A data center will have a network infrastructure, storage infrastructure, and computing resources. When you talk about network infrastructure, as we have just discussed, it's about switches, routers, LAN, cables, firewalls, uh, all these things that help the connectivity to happen. Obviously, we are storing data here, so there might be storage servers, there might be storage area networks, SAN. Okay, so data is the most important commodity today. So we need to have backup systems, failover systems. So all those things are in place. And finally, yes, to access this data, you need servers to run, right? So servers will be there, rack servers, as I just try to show you. We have racked servers, top servers, blade servers, and these will be providing the services to the computing services to the entire data center. So one thing that is very, very common that we use in a data center is called a rack server. Okay. This looks like very similar to what you are seeing here. It's a, it's kind of a, what do you say, uh, a flat horizontal structure, very much like the drawers in your cabinets, right? As the drawers in your cabinet can go in and out, these rack servers are mounted on these rails on the left and right. So basically, you can simply drag these rack servers out and drag them in. And as they are flat in structure, they are normally measured as in the height things, right? So in the dimension wise, the length and breadth remains the same, only the height varies. Okay, the length and breadth is as per the rack size. So all these are standards. So there can be a 1U, 2U, and 4U. So 1U will occupy 1U space on the rack, 2U will space 2 units of space on the rack, and 4U will occupy 4 units of space on the rack. Even the rack sizes are measured in the U units only, right? So 24 U unit or 42 U unit, so and so more. Okay. What is the benefit of it? One is very efficient use of space. So instead of, if you just imagine that you all would have all seen the tower servers, right? The tower PCs that you have in your homes, right? You must have seen that on your in your college labs, etc. Yes or no?
Yes.
So just imagine that if you have got hundreds of PCs, right? It will be very difficult to keep them on the floor. Or even if you stack them one above the other, again they can fall down, they can break, and all those things can happen, right? So the benefit of rack server is that because they are easy to mount on these racks, uh, they s- they save our space. This entire setups becomes very robust. It is easy to manage them, maintain them, and upgrade them. As I told you, you can simply drag them out, open them up, make the changes, and again put them back. Okay, so it becomes very easy. Uh, it also saves the space in a data center because on 142 rack, say you can put 20 servers in one vertical space, right? So in a way, it saves the space. If you had to keep all those servers on the ground, it would have needed a huge space to do it, right? There is a concept of blade server also, right? Basically, what happens is that blade servers uh, are kind of very compact and very thin servers, and there is a very big chases, right? So in a blade server overall, what will happen is that one box that will come from the market, it can host 6 blades, 8 blades, 10 blades in it. Okay, it's not like you will bring a rack for that. So that blade server itself will go in the rack, and that blades on the blade servers you can put multiple blades, which are themselves like a complete server unit. But on a single blade server, you can say put 6 blades servers, 6 blades on in that, right? So if you're putting 6 blades in one blade server, what is happening is that you have a very high capacity machine, a machine which can have say 200 CPU cores, a machine in which you can have say f- 5 500 GB of memory, and so on, right? Or large disk space of say 200 terabytes or something. So those kind of combinations are possible using blade servers. So if you get a one blade server, you can do virtualization on top of it. You can create say 100 virtual machines on one server. So once you have done that, so a single server is kind of being able to serve your 100 customers, right? So that is how that blade server is using. So one very important thing is that when we use a single such as a single machine, it also saves our power output or power requirements. So space requirements are reduced, your power requirements are reduced, and one more important thing, your cooling requirements, right? So when we have got these thousands and thousands of servers and switches running, they generate a lot of heat. Okay, so you need to have that much cooling also for them. So the lesser number of hardware you can put, you reduce all these kind of requirements and overall reducing the cost, and today even your energy footprint, or what you say, uh, green energy or those kind of things are all have also become very important. So carbon credits are there. You want to be running systems which doesn't consume that much of electricity and so on. So those are the other aspects also that people take care of. So key features are what? We have a redundant power supply. We have UPS generators. It should not never go down. We have cooling systems. As I have told you, cooling is a very, very critical feature. You might already know that if your devices, say suppose you are running a machine and the temperature of that machine becomes high, the performance of the machine also drops. Okay, so these machines have to work at 16 degrees centigrade or 18 degrees centigrade of temperatures, all these machines, which is their peak performance temperature. Okay, so that is how, if you ever get a chance to go into a data center, you generally have to wear a jacket before going in there because so cold there. We have fire detection and suppression. Physical security is very important. It's very difficult to get entry into a data center. Uh, so you need to take permissions from multiple levels. Only then people are allowed inside. Rack based we have already discussed, and very high speed networking, right? So these are the key features. So why are data centers important? Again, we have seen that, but again, we run business critical services. We need secure and reliable infrastructure. We need business continuity and disaster recovery. So in case something fails, we should be able to recover it from there. We want to maintain the cost and efficiencies, right? See, today we you might feel that if you are taking a server from data center, it is more costlier, but definitely the overall the benefits, if you will see that, okay, if you are keeping a server in your office, you need to ensure that you have to have a security person around it. You need to ensure it is always up. You need to ensure it has a proper power backups. It has to be like the AC has to be on 24 cross 7 and so on, right? So many things have to be considered. If you consider all those aspects, keeping a server in data center is definitely much more cost efficient. Okay, so all these things are important. Are the reasons why data centers have become so important. So just to introduce you the server room, as I mentioned before, smaller organizations may still choose to keep the servers in a server room. Here, servers are placed inside the company's own office. IT teams or admin teams will manage the power, cooling, and physical security. Um, Now, because this is a smaller room, here we are talking about a network which is either the same office or same building or maximum uh, two or three branches which are using that that server room to get services from there. There is always a risk of downtime due to power cuts, limited cooling, or hardware issues. Backups, upgrade, and disaster recovery are handled manually or locally. Right. So this is a server room. Uh, So this is the comparison. Generally, data centers are large. They are multi-layered. Power backups are there. Industry-grade cooling is there. Here, there's basic air conditioning. Uh, Generally, redundancy will be very low in server rooms. And finally, access control also is as good as the organization's access controls. So if the organization is not able to maintain a very good access control policy locally, the same thing will apply there. But in case of a data centers, you have very strict access controls. Okay, now you people might have heard about cloud a lot. The past 15, 20 years, cloud has become a most talked term in IT. Today, we all consume cloud computing services from AWS, Azure, Oracle, and so on. So how this cloud is differing from a data center, right? Essentially speaking, cloud services are also being delivered from one or the other data center only. Okay, but then why do we call them cloud, right? Essentially, the services that you use on cloud, you don't need to actually have a physical point of contact there to do stuff. Normally, cloud services are being delivered to you as software as a service. So you will actually log into a cloud portal and you will just start configuring your services and it will automatically happen. Okay. But at the back end of the cloud service, there is a data center only. Now, this data center is very big, is very huge, right? It never goes down. It cannot go down. You don't need a physical person or a person on the call to tell you what to do. Everything is available to you as a service. So if you want to create a computer, all you need to do is open your screen and click 5 6 places, do three configurations, and you will have your system up and running. A server up and running, which you can remotely access and do your stuff. Okay. So a data center in a cloud computing is the physical foundation providing location, infrastructure, and resources. Cloud is the service on the top of the physical layer. Okay. Cloud provides data center services in flexible pay-as-you-go models and globally. Okay. So these are the basic differences. Otherwise, behind the back, there is a data center only. Now coming on to one very important part of uptime, right? So why all this is important? At the end of the day, we are talking about something called uptime. Generally, when we work in the industry, there is a concept of SLA, which is called as service level agreement. So when you take a server or service from a data center, you there is a contract between you and the provider or the data center provider, data center, and in that contract, what is being discussed is that how much your services will remain up. So as a provider, I am telling my customer that if you take a server from me in the entire year, for how much time you will not be able to use it, right? So this term is called SLA, service level agreement, and this is something called uptime. So generally, you will have different kinds of data centers. People will give you an SLA of 99%, which means that you might not be able to access your servers in the data center for 3.65 days in the entire year, as compared to something called 5 nines, which is a standard today, where we say that not for more than 5.26 minutes, the services should be unreachable, or I should not be able to connect to my server, right? Now, obviously, you can see that if I'm moving from 2 nines to 5 nines, I need to make my systems much more robust. Okay, So if I am running as someone who is running a data center, if I have to provide 5 nines of SLA in the market, my systems have to be much more robust as compared to when I am just providing a 2 nines of uptime. So again, people who are providing 5 nines of uptime, they are will be able to charge more for their services as compared to 2 nines of uptime. Okay. So the more the nines, the reliable is the service, and obviously the people have to work to make that services that much reliable. At times, you also have some SLA contracts which come with penalty clauses, where we say that if if you're not able to maintain this SLA, um, you will be charged this much amount of time. Amazon Web Services claims uptime for some services as high as 11 nines, right? So S3 storage uh, has a 11 nines of uptime. So practically what you are saying is that it will never go down. Okay, it will never go down in a practical case. So this is a very important thing where you should always keep in mind. Even this SLA term is applicable to your software services, to your support services. But here we are
Sir,
just,
in ticketing also we use SLA to resolve the issue in a particular SLA time.
yeah. So that is
Means
for
customer
support
issue.
services. So
Yeah,
in
yeah, yes,
support
yes.
services, we are talking about how if a
Yeah.
issue happens, in
That
how much time you will
how
resolve
much
it.
customer is
Yeah,
affecting on the client side,
yeah,
then we
yeah,
have to resolve as soon as possible.
yeah. Then we come to data centers. So there is again one concept of data center tiers. Basically, you are talking about, uh, as you can see here, there are 4 tiers of data centers: tier 1 to tier 3, 4. And there is one more thing is of SOC 1 and SOC 2. So that is not mentioned here. So tier 4 data center is something which is the best data center that that you can set up. Normally, as I said, that they are giving you uptime of 99.995, just slightly below 5 nines. Uh, they have, so if you are taking a service from tier 1, again the same thing will apply. They are not using as robust systems as a tier 4 data center. So if you want to procure a server tomorrow, you can simply ask the data center provider in which tier they fall. And normally you will see in their advertisements also, and in their ads also, in their documents also, that what kind of tier they are, because that is the main thing that they are selling to you. Okay, so this is about it. In summary, data centers are the foundation of digital infrastructure. They offer performance, security, and scalability. Knowing how they work helps in cloud, networking, and DevOps careers. So finally, what I want to tell you is that when you talk about the data centers today, uh, and when you will be working as in organizations, you will find that there are no physical servers as such around you. You people are you just using your laptops, or maybe someone is using a PC. Even programmers, developers, support team people, everyone is just using the client side of it. The server side of things is always in these data centers, and you are accessing these things always remotely. Okay, today if you are using cloud, then practically speaking, you are never really not required to even log into your system. In a perfect case scenario, if I am using a machine on a cloud, as a user, okay, not as a developer, as a user, I don't even need to see what is happening at the backend. I can simply log into my AWS console, do 5 6 clicks. I will have my machine ready. I will log into that machine and start doing my work. Okay. Uh, so that is what is happening. Even the core IT people today, they always log into their machines remotely only. In case of Linux, where people are working on Linux platforms, they are mostly using it on the command line. In case of Windows, they are still using a remote desktop and a GUI. So this is how the entire thing is working, and that is about it. Okay. So have this topic is understood.
Yes.
Yes, sir.
Uh, can you think of a reason why we are covering even this topic like data centers? What is why are we doing this?
So to have a basic understanding of what is the difference between cloud and the data and all.
Understanding of where the servers are,
Mm.
how do we are installing and keeping the servers. Because once you start on your job, you will not be so you should know that okay, there is somewhere the data center is there, somewhere my servers are running, from somewhere we are providing a service to the customers, but it is there. Okay, so in terms of so when you will put your login names, you will put your URLs, you will put your IP addresses, so you should be able to connect the dots and understand what is happening behind the scenes, even though you are not going to work behind the scenes for now, but
Yes.
you should understand what is happening behind the scenes.